In this video, we are going to use first principle to find derivatives of function which have this form. Something under root. Now, let's look at the first principle first. We know first principle says the derivative of a function y with respect to x is given by limit del x approaches 0 del y divided by del x. We have done this in our earlier classes. Now, we are going to solve question number 1. First, we consider this to be y. Y equals root 2x plus 3. Then, we know we have to state what del x and delta y are. Now, let del x be a small change in x. We have to do this every time we are using first principle. So let del x be a small change in x and del y be the corresponding change. Corresponding change in y. We know what this corresponding change means. As x goes to x plus del x, y goes to y plus del y. This is the meaning of corresponding change. Now we find del y. Why? As y goes to y plus del y, we put x plus del x in terms of x instead of x. And then we bring y to this side, so it becomes minus y. So that delta y becomes 2x plus del x plus 3 root. Our y is root 2x plus 3. So it is minus root 2x plus 3. Whenever we are calculating limit and we find something root minus something root or something root plus something root, if we get indeterminate form, I've already talked about it in our earlier classes, that we'll get 0 by 0 form whenever we directly try to calculate this limit. Right? So we have to manipulate y, delta y. So in this problem, we'll manipulate delta y by multiplying by conjugate. This is done by multiplying by conjugate, which is conjugate for this term is nothing but we change the sign here to plus. That is root 2x plus del x plus 3 and then plus root 2x plus 3. Okay. These are conjugate. We cannot multiply just above. We'll have to balance it out. So we have the same thing in the denominator. Okay, these are way to eliminate the indeterminate form. Now we multiply these two. This is a minus b. This is a plus b, which is equal to a square minus b square. Therefore, it becomes a square means this term is squared, right? That is, the root will be cancelled out. So we are left with this term. And here, minus b square means square of this term. Here also, the root will disappear. So it will be minus 2x plus 3. So these two multiplied, we get this. On the denominator, we have root 2x plus del x plus 3 plus root 2x plus 3. Now let's evaluate this numerator. It is nothing but 2x plus 2 del x plus 3 minus 2x minus 3. We open bracket with this minus. So here 2x cancels out and 3 also cancels out. So it will be 2 del x on the numerator. Therefore, it will be 2 del x divided by the denominator is same as before. This plus root 2x plus 3. So now these are delta y. Now we simply put this in the definition of derivative. From first principle, we know dy by dx is equal to limit dy by del x. So we replace del y by this term, so that becomes 2 del x divided by root 2x plus del x plus 3 plus root 2x plus 3. This is del y. We have divided by del x. So 1 del x will come here. Or maybe you can write it here. It's no problem. Let me write it here. We will have del x here. So this del x will cancel out. And we're left with this term. Now we simply put 0 in place of del x. So this becomes 0. That means it will be 2 divided by, this will be 2x plus 3. This is also 2x plus 3. So root 2x plus 3 plus root 2x plus 3 is equal to 2 root 2x plus 3. So on the denominator we have 2 root 2x plus 3. And this 2 will cancel. Therefore, the derivative is 1 by root 2x plus 3. These are derivative. One thing, derivative is also called differential coefficient. Remember, if the question asks to find differential coefficient, it is asking for the derivative. Okay. Now we'll look at the second question. In the second question we have 1 divided by root x. And we have to find the different derivative of this function. So first we let y equals 1 by root x. Then again language, we state what del x and del y are small change in x, and delta y with the corresponding change. Okay, corresponding change in y. Now again we find del y by writing y plus del y in place of y and x plus del x in place of x in the original function. So again we bring our y over here, and it becomes minus y, so that del y is equal to 1 divided by under root x plus del x minus 1 divided by root x, because y is equal to 1 divided by root x. Again we'll have to manipulate y. Okay. So what we'll do is, this is a fraction. So we take the LCM and multiply these two. It becomes root x plus del x, and denominator we have root x multiplied by root x plus root x. Again there is root something root minus something root, so we need to conjugate, multiply with the conjugate. Conjugate for this is, simply change the sign to plus root x plus root x plus del x. We cannot multiply just with the numerator, we have to balance it out. So when you do it on the denominator as well. If you multiply these two, again it is a minus b plus b, that is a square minus b square, which will simplify to c. These are a, these are b. So a square is root x square, that means root x square is x minus, and this b square means the root will disappear and it will be x plus del x. And when we open the bracket with minus, it becomes minus minus. So in the numerator we will have minus del x only. So it is equal to del y is equal to minus del x divided by this whole term multiplied. Right? Root x, it is root x plus del x. And here we have root x plus root x plus del x. So these are del y. Again, now we will replace del y in our definition. So from first principle, we know dy with respect to x is given by limit del x equals to 0, del y divided by del x. So del y is this term here. So it is del x minus with the minus sign again. Minus del x given by root x, and then root x plus del x, and here we have root x plus root x plus del x. This is del y divided by x, means there is a del x in the denominator. So this, now what we'll do, this del x will cancel out. This means the indeterminate form is removed. Now we put 0 in place of del x. So this is 0, this is also 0. So this will turn out to be root x only. This is root x. Here we have root x plus root x. This is 2 root x. We have root x times root x means root x square. That means it is x. Now we have 2x times root x in the denominator. In the numerator we have a negative sign, that means minus 1. So dy by dx is equal to minus 1 divided by 2x root x. Now since we have x here, let's multiply these two. Here x power 1, this is x power 1 and this is x power half. So when we have same base, what we do? We add their powers when we are multiplying. Correct? So we add 1 plus 1 half, which is nothing but 2 plus 1 divided by 2. This is 3 by 2. So total power for x is 2x 3 by 2. These are derivative for 1 by root x. Okay. Later on, we are going to state some rules for derivative so that it will be easier for us to calculate derivative faster. Okay. And remember, whenever we get root something minus root something, we'll have to take conjugate in order to remove the indeterminate form later on. So we'll manipulate del y such that del x will be separated. Earlier in our class, we stated that if we get del x times something, we can eliminate the indeterminate form, because when you divide by del x, this cancels out. So to make this, we have to take conjugate for this form. Okay, for these forms. That's root something minus root something. Thank you.